Welcome to Module 9, and I think technically we're in Chapter 10 or 11. It is 10. So in this chapter, let me start off with, this will be probably the longest video for this module because this is going to lay the foundation for everything else. Now, the videos for this module, I'm going to let you know as I go through them what's important, what you need to have as a key takeaway for the quizzes and the projects. And I am going to cover things beyond that, but I'd like to say the last video should not have much, if anything, in it that you're going to be evaluated on in the graded notebook or in the quizzes. I'll let you know as we go through things what's the big takeaway. So in previous videos, I've talked about, in brief, the concept of objects in classes. I've used phrases like functions and methods. We've used words like variables in the past, or attributes. And essentially, I want to focus on, in this module, the foundation for object-oriented programming, specifically for Python. But once you understand object-oriented programming in the context of Python, the other languages, and not just languages, other things in IT, other things in life will make a little more sense. I'm not saying this is going to be some life lesson, but this is potentially a very complex concept if we let it be. But when we look at it from a certain perspective, it's not all that bad. So Python is written on the C programming language, and it runs on all kinds of operating systems: Windows, Linux, Mac, and others. And when you run the Python application, you're starting up the Python runtime. And then that runtime defines all the rules that make up Python, and the things that make Python what it is. So a lot of interesting details regarding the implementation of runtime, but I'm not going to deal with that right now. Right now, we're just going to focus on object-oriented design, what objects are, and all the little concepts with that. Now, objects, I want to look at them from two perspectives. A traditional real-world object and an abstract object. And when I look at them from these two perspectives, something that's real-world is something that you've come in contact with potentially in your day-to-day life. Let's say a cat. And in this first example, I start talking about a cat object. Let's go create an instance of a cat. And what attributes do cats have? Well, cats have names, they have age, they have weight, they have color. So those are things that we can use to describe that object. Now, the class itself, all cats have those, don't they? They all have an age, a weight, a color, and in theory, a name. And if I just make a clone of a cat, it would have all of those that it would inherit from the parent class. So if I wrote a class of code and said, hey, I'm going to create this class, and by default, the cat will weigh 2 pounds. It will have orange striped fur. It will be named Kitty. and it will have an age of 1. Those are all default values that I set so that every time somebody creates an instance of this cat, it's the same base model, if you will. When I say base model, a lot of times people will use the example of cars. And a car is a good example of object orientation. And those are real life examples. They're not abstract. Now, in past modules, we've discussed things like lists, strings, float, int, boolean. Those are classes. Somebody created code to define the structure of what a string is, of what a list is, what functionality needs to come along with it or go along with it, what attributes should a list have, what can it do, can't it do. And since those classes exist, we can create an instance of them, or a copy of it, if you will. We don't have to necessarily go with the base model. We can customize our list, or we can customize our string by setting certain values to be whatever we want. I want my cat to be named Oscar. Well, that sets my cat apart from other cats. Other cats may not be named Oscar. Now, the object itself is an instance of the class. The class is the type. Now, in the past, we've used that type function, type followed by parentheses, and we pass that function whatever it is we want to find out. What type is this? What data type is this? And when we say data type, it's not necessarily type of data, it's what type of class it is. What was the parent class that this thing is a copy of or a clone of? Oh, somebody created an instance of an integer. And here it is. It's named num. Somebody created an instance of a string. It's named last name. So with those ideas in mind, the real world ones, cat, car, that's real world. We don't see a class of numbers or a class of strings or a class of lists in a real world environment. Those, we'll call those abstract. Somebody has come up with that imaginary concept. We may be able to create a grocery list, but that's different than the lists that we use in object-oriented programming in Python. So with that said, let's go look at some examples. Now let's say we want to create an object called cat. So I'm going to, I shouldn't say create an object, I'm going to create a class called cat. And initially I used the pass keyword, and you remember what that does. It is a placeholder so that this class can actually exist without throwing an error. So if we ran this code, it's explicitly defining a class as cat. We've got another one here. It's implicitly doing it because it doesn't have the parentheses. Okay. So it's not required to have parentheses in Python, but please do. Just get used to doing it a normal or traditional way. So we've defined this class. It has no attributes or functionality. It doesn't do anything. And I can create an instance of it. So here's the cat class. A cat equals cat. So in essence, I'm saying, take this cat class and make a copy of it, and I'm going to call it a cat. I didn't pass it any values to say, set his name to be this, set his age to be this, his color to be this. We'll deal with that a little bit later. But in essence, here's the class, create a copy of it, and I want to start out with specific words that you need to get used to. We're creating an instance of the class. An instance of a class is an object. We call it instantiation. So there's a class called cat. We create an instance of it. It's like creating a copy, a clone, if you will. And that is an object that we name whatever we want it to name. Now, we talked about names before, and those names need to be unique. You don't want to have the confusion of, well, which one were you talking about? So it needs to be a unique name so there is no confusion from one to the other. Now, when we initialize this class, in Python, there's this unique way of doing things, and we see the two underscores in front of it and two underscores after it. And I know it looks odd. Why would you put two underscores? Well, this is something that's pretty unique to Python. And it's a built-in method that allows you to initialize or create this object. So in this example here, we've declaring this cat object, or cat class, excuse me. This class is named cat. We're going to create instances of it or copies of it. And every time we do, this init method is going to get called or triggered. It's going to happen automatically, and it happens when we instantiate or construct our object. Now, the word self can be kind of confusing. And self essentially means we're talking about this class. Not necessarily this class, but this instance of the class. So when we go to build this thing, create an instance of this class, we have this method, the init method, that says, what do you want to initialize? The cat class. Well, what is it that you're naming? You're going to pass it a name. And it will set the name of the object you're creating to whatever you pass to it. Now, I'm going to back up a second, and or I might even jump forward a little bit. There's terms that we see used in other languages more than we will see in Python, and I'm going to get to them here shortly. But essentially, they're constructors and deconstructors. Constructors build things. Deconstructors tear things down. So if we're looking at this instantiation, creating an object, we're essentially constructing an object based on the template that's been provided. And the template is that class that's been written. When we construct, we have the ability to pass some values or determine some values from the onset. So I'll perform my construction using the constructor and pass values to Python. Python will then take those values and initialize, that's what's happening here, initialize an instance of this class. So when I create it, let's back up, I created it here. Create a class called acat. This is the constructor where I call that class. I'm constructing an instance of it. I didn't pass it anything in these parentheses, but I could have. And if I did, it would get passed right in here. Get passed right in here where I initialize something. I'm initializing the building of this class cat. Building of an instance of the class cat. Okay, so this is the constructor. I didn't necessarily have to pass it anything because when we look back here, there's nothing going on in it. When we look here, there's still nothing going on in it, but we created the place to initialize what's happening. In this one, we're creating a way to receive a name in, and it receives the name and it assigns the name to self. Now, self is what? Self is this object that we're creating. So when I use that constructor here, and I've got it right here in this line, I'm going to create an instance of cat, and I'm going to call it furball. I'm going to pass it a value, grumpy, and that's the cat's name. And it will come right in here in the initialize, in the init method. And then what happens to it, we've defined that. So in this constructor, we had the opportunity to create a name. And I could have come in here and put a default name. Name equals Fluffy. Whatever I want it to be. And if I called cat and didn't give it a name, it was ready for me. And that's something that we've dealt with in previous modules. So here's our constructor. We instantiated cat. We created an instance of a cat class. And what's the name of it? Furball. So we have an object named furball. The type is cat. It has an attribute called name, which is grumpy. So anything that's going on in the construction of this cat object called furball, furball is the self. Furball is the self. So it's like saying furball.name. Now, why do we say self? Because every time we create another cat, it's going to have a different name for that object. So we just had to have some generic name to refer to the name of the object. Okay, so that's where this word self comes from. Self is the name of the object itself. So when I print, here's a string literal constant, comma, and then I pass that print function furball.name. Furball is an object. I created it. And it's an instance of cat. You see it? Right there, instance of cat. furball.name, name is an attribute associated with that object. Now, these objects, they have, and we think back to strings and integers and floats and lists. Think back to things that we've done already. And those are all instances of classes. So when I declare a variable called num2, that's a data type float. Data type float? No, it's an instance of the class float. And it inherited all of the attributes or potential attributes associated with float. And float also had a bunch of different functionality or essentially methods associated with it. Things it can do. Somebody's already written those methods, like, I want to sum whatever that is. I want to round whatever that is. So there's functionality associated with that class that is inherited by the object that we've created. So kind of think about it like a parent and child. If the original class is the parent, the object that we create is a child, and it inherited certain attributes from the parent by default. Now that doesn't mean I can't set other attributes to certain values. It just means that's how it was created. Okay. So let's look at an instance here. I want to create a class called employee. And when we construct this instance of an employee, it's going to invoke or call this init method. I don't have to pass it anything. And it's going to have this attribute called emp title. So by default, each employee that we create is by default a manager. They have the emp title of manager. Everybody does. So when I run this thing, it's going to define the class, and I've got two methods in here. One is that initialization, and the other is, it's a print method. And it's a way for me to get some information about whatever's taken place. So this is some functionality I want to have the ability to perform. I want to be able to do something. So when I create an instance, here's my constructor, create an instance of employee, and it's called obj. So now I have an object called obj. Class object. Object obj exists. It's an instance of this employee class. It inherited whatever attributes and functionality employee had. And when I call the print employee function that's associated with the employee class, it's inherited. The obj, or the object that I created, has that functionality by default. It came with them when I created them. So obj.printEmployee invokes that method right there. And it says print self.empTitle. Self is obj. EmpTitle? Well, what was the empTitle? We defined it right here. We put a value. We declared it and initialized it with a value. In the init method, we put that print function to show we were in there. Something happened. That's why I had this come out. We want to see that some value was actually set in the emp title associated with our object that we've just created. We created an instance of employee called object. So, in a way, like I said, it's like cloning. And these classes, the class itself, the parent class, can have attributes and methods. Now, methods are, it's like functions, and I've called them functions in the past, and depending on the language we're talking about, they may call everything a method. In C, C Sharp, C++, they call everything a method. Whether you create it or it's an instance, it's part of the class. It's all methods. They're interchangeable for the most part. In Python, if we're talking about a method, it's functionality from the parent class. So we've got attributes, and we dealt with an attribute here. And it's like a variable, right? So I can have as many of these as I want. I can set defaults at the time that I initialized this object. I can declare whatever they're going to be. So this class cat doesn't do anything. I created an instance of it, and I printed off, there's what am I printing? The instance of the object, or instance of the class. I'm printing off the object. And here it says main.cat object. That's what it's returning? It's returning what it is and essentially where it is. It's an instance of a cat object here. Oh, you created another cat? Here's an instance of it, instance of cat, and it's over there. So they're copies of the same class, or instances of the same class that are objects, and here's a location where they can be found. This is important in that I want you to understand, when I store things, when I store variables, they have value, and that value is an attribute. When I say, hey, what's in that variable? This value. And some classes don't have necessarily value that can be returned. So when we go to look to see, hey, what's in there? I don't have anything to give you, so here's where I went and looked, and this is what I was looking at, but it didn't give me anything to provide you to, nothing got returned. So we can assign some values to attributes associated with this cat object that we've created. But when we look back up there, a cat, the parent class, it didn't have age, name, nemesis. My object does. So it inherited certain things from the parent, but that doesn't mean it's limited to only what it inherited from the parent. It can have more. And we can define that as we build our objects. How do we access them? Well, I declared what it was here. I said, hey, I've got an instance of cat called a cat, and I'm going to declare a variable or an attribute called age and initialize it with this value. Name, initialize it with this value. What is this right here? That's a number. What is this right here? That's a string. So this attribute has certain things that it's inheriting from a different kind of class, string class. So we're not only dealing with a cat, we're dealing with a string object as well. Functionality, these methods, same kind of concept. So when I create an instance of a class and when I create my object is not just one object. It could be an object that's comprised of multiple other objects in it. So if I want to go print this off, here I've got print, string literal constant, comma, and then let's go get whatever's in that storage location. Let's go get whatever's in this storage location. Let's go get what's ever in this storage location. And I've stored things there. Boom, 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 boom. Now, when we go print them out, ACAT age, we know what that is. I stored 3 in there. I stored Mr. Fuzzy Buttons in the other one. ACAT Nemesis, there is no, what did I put in Nemesis? Another cat. It's an instance of cat. So it's an object. I took some attribute and I stored an object in there. That object doesn't return anything. So this is what I was just talking about earlier. It says, hey, go get Nemesis. Now I went to Nemesis. It's an instance of cat. And here's where it is, but it didn't give me anything. I went to acat.name. It's a string. And here's what it gave me. If I said type, it would tell me it's a string. It's not going to tell me where it is because it didn't go and receive nothing. It actually got returned something. So these are ways for me to define and assign values to attributes. I said that we have constructors and deconstructors. In Python, we don't do it the same way we do in other languages. In Python, we have the constructor is init, and we have a destructor, which is del, or delete. When I'm done with an object, I want to get rid of it. I don't want to tie up space in memory. I don't want my runtime carrying baggage, if you will. So everything that I create in runtime, when you think of runtime, think about it like a marathon runner. Everything that I create during that race in runtime, that marathon runner's having to carry around with them. And if I'm not using it, let me go ahead and destruct it or delete it. So when I create my class, I have an init. That's what's called when I construct. And I have a del. This is what happens when I destruct. Now, here's where I initiated it or instantiated the employee class, called it obj. That's the constructor, it called init. Here's the destructor. It's a destruct obj. And that called this one right here. And shut it down. So this deleted obj. Okay. That's the gist of this first video. And we'll come back and we'll talk more about it when we talk about inheritance. But this is the foundation of it. We have a class. It has attributes and functionality associated with it, attributes and methods. And when we create an instance of that parent class, that instance, or the object we create, inherits everything from the parent. And we'll talk about that in the next video in inheritance.